in this problem, we are given that angle A is supplementary, I'm just going to abbreviate that, to angle DEC. Let's highlight those two angles here. Angle A and angle DEC sum up to 180 degrees. And we're going to be asked to prove, proposition is, the ratio between BE and AB is equal to the ratio between BD and BC. So let's prove this. When I first looked at this problem, my thought was that, well, maybe I can do something with the parallel postulates and sit there and be like, oh, supplementary angles, awesome. Well, these guys are going to be parallel. Okay, no, DE and AC are not parallel. They would be if instead of A supplementary with DEC, it would say A supplementary with ADE, this angle over in here, or DEC supplementary with angle C, something like that. Those two angles on the same transversal, but these are on different transversals. Okay, well then my next thought was to sit there and say, well, these two are supplementary. ADEC is a quadrilateral. Quadrilaterals have 360 degrees in them, so that means this angle, ADE, and this angle, C, are supplementary. Okay, so then I can set those equal to each other and I can start solving it out and get some congruence and show that, I kind of stalled out there and I'm like, that's way too complicated. There's way too much going on there. What you really want to look at when you're looking at this problem is take a look at the sides here. We need BD, that's this side, and BC, that's this side. And they've got to be the same as, switching colors again here, we'll go for red. AB, this big side here, is to BE, this side here. So it looks like we're going to have to do some similarity. This form right here is a dead giveaway. We're going to look for similar triangles. And it looks like this angle A should be congruent with angle DEB. Can we show that? And the answer is yeah. Take a look at angle BEC. It's a straight angle. Measures 180 degrees. That means that DEC, DEB have to sum to 180 degrees. So angle DEB is supplementary with angle DEC. Because that's a straight angle. And we know that A is supplementary with angle DEC. That was given to us. So once again, a little transitive property in action. These two guys are going to measure the same. Angle A is congruent to angle DEB. We'll go ahead and we'll call that transitive. So the next thought looking at this guy, we've got these two angles congruent, these two green angles. We've got them congruent. My next thought looking at it was, okay, I need another angle. I have no idea how I'm going to pull that off with these two angles here, angle BDE and angle C. Maybe I could make that whole quadrilateral, there's 180 degrees left over type of argument, but we don't need to. We don't need to get into anything revolving around quadrilaterals. We just need to take a look at angle B. this angle B is in triangle ABC. It's in triangle EBD. We've got our two angles. So we'll go ahead and we'll write that down. And just for kicks, we'll make use of the reflexive property. Say that angle ABC is congruent to angle EBD, reflexive. Different name, same angle. It's congruent. So that gets us triangle ABC is similar to triangle EBD. Super, super, super important here is the order. Remember, which two angles were congruent here? Which angles did we have congruent? We had A, and we had this angle E here congruent. The order in which we list those angles when we write the similarity here is super important. Otherwise, we don't know that A is similar to E, or excuse me, congruent to E. And this was by show two angles similar, or excuse me, two angles congruent. Angles cannot be similar. My apologies that I keep slipping there. So that's from angle similarity, that these triangles are similar, which now that we have similar triangles means that BE is to AB as BD is to BC. The ratio between those pairs of sides is the same. And that's that. Well, until next time, happy geometering.